Hey guys, welcome to this video lecture series on the subject of energy technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. In previous video, we have just started the chapter of geothermal energy and we have seen different sources of this geothermal energy. And we have discussed the hydrothermal convective system, in which we have discussed the flashed steam system. Well, in this video, we are going to discuss next type of liquid dominating system, and that is binary cycle system. Well, this binary cycle system, you can see in this animation that it utilizes two different working fluid. One is the, of course, hot geothermal fluid, and another one is the heat transferring fluid, which is essentially having lower boiling point, so that we can convert it into vapor state. Well, this secondary fluid is need to have volatile in nature, so that we can easily convert it into vapor state. The secondary fluid has much lower boiling point than the geothermal fluid, so it flashes into vapor and drives the generator. Here in this animation, you can see how we are extracting hot geothermal fluid and sending it to one heat exchanger so that it transfer its heat to the organic fluid. This organic fluid in a vapor state then sent to turbine section, where it rotates the turbine and produce electricity. Well, here in this image, you can see typical diagram of binary cycle system, where we are extracting this hot geothermal fluid from the production well. This hot geothermal fluid is pumped through the heat exchanger, where it transfer heat to the organic fluid, which is then sent to turbine section, where it runs the turbine and rotate generator. This generator shaft cuts electric magnetic field and produce electricity. Well, now this steam exhausting this turbine section is then sent to direct contact condenser, where we cooled and regenerate by means of air cooled or water cooled condenser, so that we can repeat cycle and produce electricity continuously. Well, binary cycle system utilize the secondary fluid for the power generation. Hence, there is no problem of corrosion or scaling in the working component such as turbine and condenser. However, the temperature and salinity of brine are higher, then it creates fouling and scaling problem in heat exchanger, which ultimately reduces the efficiency of entire binary cycle system. So, this is what all about the binary cycle system. Now, let's discuss about some of the vapor dominating system. Well, these vapor dominating system are most attractive geothermal resources, since they are easy to develop and available at moderate depth up to couple of kilometers deep in the earth crust. They have lowest cost and least number of problems. Well, here in this image, you can see the typical diagram of vapor dominating system. We are extracting dry stream at 200 degrees Celsius, which is superheated in nature, and we are sending this steam to one centrifugal separator, where we separate the different gases dissolved in this steam. Then this steam is passed to turbine section, where it drives the turbine and rotate generator in order to produce electricity. Well, this steam is then now sent to condenser. Well, we have kept direct contact condenser for this case, so that we can directly convert this steam into liquid form, and we re-inject this brine coming from the turbine to the earth crust. So, this is how one typical vapor dominating system works. Well, this liquid dominating system and vapor dominating system combinedly is very important for the exam point of view. It has been noticed that this question has been asked for 7 marks in many university exams. So, now let's move to the next topic, and that is geopressured resources. Well, the abnormal high pressure and temperature of water up to 1350 atmosphere in the depth of earth crust hold greatest amount of energy potential and are known as the geopressured resources. So we know that at the core of the earth the temperature and pressure is significantly high as 1350 atmosphere. So that gas present near to the core of earth are very hot, so we can utilize this heat energy in some another form to produce electricity or maybe for space heating. Well, this geopressured hot water reservoir were apparently formed by accumulation of geothermal heat stored over the several million years. A special feature of this geopressured water is their content of methane. Well, the solubility of methane is very low in water at normal pressure, but at higher pressure the methane is very much soluble in water. So when this water comes to the ground or comes to the earth surface, its pressure reduces and methane gas, which is dissolved in water, get released. So we can easily separate this methane gas out of the hot water. So when this water is brought to surface, its pressure reduces and it converts into gas. Now let's move to the next resource of geothermal energy, and that is hot dry rock resources or petrotherm resources. Well, petro means stone. So energy associated with rock or stone in the earth crust is referred as hot dry rock resources. The petrotherm system are those systems that are composed of hot dry rock but no underground water. So that means there is only hot dry rock but no water. These hold by far the largest geothermal energy resources available. Well, rock with temperature exceeding about 200 degrees Celsius at moderate depth of 5 km are significant and worth to explore. So we are now developing such resources and creating these hot dry resources for the heat application. Well, the principle of this HDR, that means hot dry rock, is to recover heat from the hot dry rock that involves breakup or cracking of this rock. Well, we create crack so that we can facilitate the water flow in order to extract or pick up the heat of this hot dry rock. There are basically two different methods to tap this geothermal energy. One is to detonate a high explosive at the bottom of well and drilled into the rock. Well, the another method is to use hydraulic fracture to produce heat transfer surface and extract heat at high rate from these hot rocks. So we will see this how we are utilizing this hot dry rock to produce electricity or for the application of space heating. Well, here in this image you can see that we have one hot rock around 300 km deep inside the earth crust. We are creating hydraulic fracture over this rock by passing high pressure water. So this generate heat transfer surface and facilitate the water flow. Now heat is extracted by pumping water through a well that has been drilled to the lower part of the fractured rock. Here in this image you can see that we have created one fracture at the bottom of the rock and we are passing water to this crack so that this water picks up the heat of this hot dry rock. Now what we are doing is we are creating another well, so this water converts into the steam and it sent to turbine section where it drives the turbine and produce electricity. Well, in order to do this we need to create a second well and we have to drill this well so that we can facilitate the flow of steam to the turbine section. Well, there are certain problems with this hot dry rock system, that the leakage of water underground and the necessity of makeup for these resources above the ground. Well, the effect of water on the composition, since the material is carried over by the water flow, and cost are some of the major problems associated with this HDR system. This system requires two wells, while the hydrothermal energy source requires only one well, which increases the capital cost of this entire plant. So these hot dry rock resources are relatively costlier than hydrothermal resources. So this was all about these hot dry rock systems. Well, this question is also very important for the exam point of view. This single source is being asked for many times in exams. Now let's move to the next geothermal resources, and that is magma resources. In the vicinity of relatively recent volcanic activity, the molten rock, that is what the magma is, occur above the temperature of 650 degrees Celsius. The large volume of this magma make it sustainable source of geothermal energy. Well, how do we can extract this energy from magma? In order to do this, we have to put one heat exchanger within the magma, so that we can transfer this heat of magma by passing it to the secondary liquid. And this secondary liquid is converted into vapor form, which drives the turbine and produce electricity. So this hot liquid could be used to produce working fluid such as steam to operate turbine and electric generator. The liquid would then be recirculated through the heat exchanger in the magma, so that we can repeat the cycle and produce electricity continuously. Well, there are certain problems associated with this magma resources. One is to construct this heat exchanger that can withstand high temperature and pressure of magma, and to maintain the flow of viscous magma around it. So this is not the easy task to build or to construct one type of heat exchanger that can withstand the temperature and pressure of magma and facilitate the flow of viscous magma. Well, the capital cost of discovery, development and installation of these magma resources is very high. So now let's move to the different advantages and disadvantages of this geothermal energy. It is also very important question for the exam point of view. The geothermal energy delivers great amount of net energy compared to other non-conventional sources of energy. Well, geothermal power plant has highest load factor around 85 to 90% compared to 40 to 50% for the fossil fuel plants. This geothermal energy is least polluting compared to other resources. So we can clearly see that we are not involving any kind of fuel in this geothermal energy. So it is not creating any pollution effect. The greatest benefit of this geothermal energy is its flexibility for multiple application. We have already seen how we are using this geothermal energy for multiple purpose. Now this geothermal energy is versatile in nature and it is cheaper compared to other resources. So this was all the advantage of this geothermal energy. Now let's discuss some of the disadvantage associated with this geothermal energy. The overall efficiency of power production is low with this geothermal energy. It is around 50% compared to 30 to 40% efficiency of fossil fuel plant. Well, the withdrawal of large amount of steam and hot water from hydrothermal reservoir may result in surface collapsing. So if we continuously extracting this steam and hot water from the earth surface, it could create landscaping problem. The steam and hot water coming out of the earth surface may contain different components such as H2S, CO2 and ammonia. If somehow these gases are liberated or vented into the atmosphere, they can cause serious problem of pollution hazard. Well, the drilling operation of this geothermal energy is very noisy and it required large land area to explore this geothermal energy. So this was all the disadvantage of this geothermal energy. Now let's quickly see some of the application of this geothermal energy. Well, we have already discussed this geothermal energy is being utilized for multiple applications, but its main application are for the generation of electric power, then it is industrial process heating, and lastly we have space heating of various kind of buildings. So let's see how we can utilize this geothermal energy for the process heating. Since geothermal energy is available in many countries, they can be utilized directly for the heating application in industry. either in the form of steam or in the form of hot water. So this is how we can utilize this geothermal energy for industry. Well, this geothermal energy can also be utilized for space heating. This geothermal energy holds great importance in some countries of Iceland, where around 50% of population utilize this energy for home heating. Space heating by geothermal energy causes minimum pollution problems. Since there is no smoke involved in this geothermal energy, it creates no pollution. In house heating application, generally central heating systems are used. The hot water usually is then admitted directly into this sewage system so that it does not create any pollution. The next application is in the agriculture and related application. Geothermal energy for heating greenhouse is important in number of countries where climate is cold. Well, the crops that utilize this heated greenhouse are different flowers, tomato, cucumber, and different vegetables. So let's move to the last application of this geothermal energy, and that is climate variation. Geothermal energy today has been only explored for the power generation and a small amount in the space heating application. Well, geothermal energy of warmer climate can also be used for cooling and processing application. So this concludes all the application of geothermal energy and the chapter of geothermal energy. We will see you in a next video. Till then, keep watching, keep learning. Thank you.